talked last time about databases, flat ones and relational ones, and looked briefly at how each of these can be used. And we've spent a bit of time looking at spreadsheets like Excel, because these can be very useful and easy to use platforms for flat databases. This session, I want to talk about accessing data from external sources. And by external, I mean external to the database itself, like company QA systems and web-based sources. But before we look at that, I want to think about the practicalities of getting the data into a usable format. Most data-centric systems these days, whether in-house or web-based, have facilities through which their data can be filtered to include only the bits you might want and exported in a format that can be read by spreadsheet software. Now, this is great if you want to use the spreadsheet as the database itself, but even if you're using dedicated database software, spreadsheets can be used as a staging point for the process of importing data from other systems. In this way, you can use the strength of the spreadsheet software to manipulate the imported data into the format that suits your database, and then paste it into your database for subsequent analysis. As a technical side note, you'll probably find a number of different options for how exported data can be formatted. A typical format, which is readable by most software packages, is what's known as comma-separated values. In Excel, the file carries the .csv suffix, and it means just that. Within the electronic file, the data is stored purely as attributes and respective numbers separated by commas. Most spreadsheets can read this format, so if you can't find an export format that is directly relevant for your spreadsheet, but you're given the option to export data as a CSV file, then that's usually the way to go. And as I said earlier, once you have the data in the format you want, you can copy it into your database. I want now to work through an example of accessing external data, just to give you a feel for how it can work. So let's say we want to get hold of rainfall data for our area in the past year so we can add that to the poppy growing trial database. Where do we start? Well, we engage the services of a large and well-known search engine. I searched for BOM, that's the colloquial term for the Australian Bureau of Meteorology, and climate data, and came up with this page. And because we're growing poppies on Table Cape near Wynyard, I entered the appropriate info into that page. And then I hit the Get Data button, which resulted in this window appearing. So that's all well and good. The data is there and it's what we want, but how do we get our hands on it in a way that we can use it on our computer? Firstly, in this case, we decide if we want all the rainfall data for this site or just for 1 year. In this case, I clicked on 1 year of data, which prompted the next dialog box to appear. This offered the option of saving a compressed, zipped folder, which contained a text file and a CSV file. The text file contained information about the source of that data that we had downloaded, and the CSV file contained the data itself, complete with a friendly warning about the file format, which just means that the first thing to do is to save the file in an Excel format. From here on in, with some knowledge of Excel, you'll be able to select the data you want, rework the layout if necessary to suit your database, and then copy the downloaded data into your database. Of course, this is just one example of the myriad data sources you may need to access, and one way of getting the data from the cloud into your database. The best way to get familiar with this system is to have a play. Try some things when it doesn't matter, so you're ready to go when it does. I want to spend the last bit of time in this session looking at a few online data sources, just to give you a feel for what is available. The first is a site in which the BOM climate data mentioned earlier is housed. This site freely provides outlooks, summaries and long-term records for all their stations in Australia. The next is the Australian Government site maintained through the Australian Bureau of Agricultural and Resource Economics and Sciences, otherwise known as ABARES. Again, there's an enormous amount of freely available data and information on this site that is designed to be useful for agribusiness. And finally, for this session at least, Here's a commercial offering boasting a live database of the purchasing decisions, operating details and opinions of over 200,000 farms. Now, this certainly isn't an endorsement of this company, but gives you an example of how the value of well-maintained and curated data is being commercialised. And if it is being commercialised, there must be commercial value in the information that is being gleaned from all this data. Our challenge, in this case, is to understand the value of this data for our businesses. That's about it for this session. Next time, we'll have a look at how we can communicate data using graphs and other visualizations to help us understand what the data is telling us and also to help us get our message across to others efficiently and effectively. I'll see you then.